Hey boys and girls, today we're going to talk about circles. There's a lot of vocabulary with this lesson, so you might want to actually take some notes today and write this stuff down so you don't forget which is which. So a circle is a plane figure, so that means it's a flat figure. And then all the points on the circle are the same distance from the given point, which is called the center. So here's our circle, and sorry, that wasn't a very good center. Here's a center point, and that center point is usually labeled with a letter. And so we would refer to this as circle P, and everything from the center to the edge or from one edge to the other is the same distance around a circle. So the circle is always named by its center point, P. So that's the first thing you want to know about circles. Circles have different parts to them. So here's circle, I'm going to call this circle T. And if I draw a line segment from center T to the edge of my circle, this is called a radius. And it is half the distance of the circle. So it is a line segment with one endpoint on the circle and one endpoint on the center. Okay, so this would also have a letter. So the radius, this is line ST, is a radius for circle T. Okay, we can have more than one radius. I could have TV, for example. So radius TV, line segment TV, or as we know, VT, radius, or circle T. So we could say that line ST and line TV are radii. Radii is the plural for radius. So more than one. Okay. Let's see, what else? What do we call the line that has an endpoint on the circle, passes through the center, and has an endpoint on the other circle? We call that a diameter. So a diameter, sorry, this is really hard to do with my phone and holding the paper. Diameter has endpoints on the circle. Has both endpoints on the circle and passes through the center. Okay. That part is really important because in a minute we're going to learn about another line that can be on a circle that does not pass through the center. Okay, so if we have, and of course these would have labels as well. So line BC, or line segment BC, is a diameter for circle T. We could also have a line that goes from S to C. Okay, so here is a line segment that has endpoints on the circle, both endpoints on the circle, but does not pass through the center. We call that a chord, C-H-O-R-D, so a chord. Okay, so a chord has both endpoints on the circle, but does not pass through the center. Okay, so there you go. Has both endpoints on the circle, but does not pass through the center. So in this case, line segment SC on our circle up here is a chord. Now, the diameter is actually considered a chord as well. It is a special chord. Because it does pass through the center, so it's a special chord. So it's still considered a chord, it's just a special chord because it passes through the center. So the diameter, it's spelled chord wrong. A diameter is a chord, but not all chords are going to be diameters, right? So we could draw two endpoints here and draw a little line here and call this DP, can be any letters. DP is a chord, but it is not a diameter because it doesn't pass through the center. Ooh, excuse me. Okay, so those are all our vocabulary words. We have circle, radius, radii, diameter, and chord. And we're going to take a look at an example in the book. Okay, so here is a circle with some different line segments. I'll hold this as steady as I can. All right, so it says, the first one says to name 6 points on the circle. So I'm on page 332, if you're not there yet. Okay, so 6 points. So point N, point L, point J, point H, point I, point K. Oh, on the circle, so H doesn't count. So N, L, J, I, K, and M are all on the circle. H is the center, so it's not on the circle. But the name of this circle is circle, as you see from the directions, circle H, because the center point is H. So now it says to name 5 line segments that are radii, so that have one endpoint on the circle and touch the middle. So LH, JH, IH, MH, KH are line segments that are radii. Now it says name 3 line segments that are chords and which one is not the diameter. So KJ is a chord, ML is a chord, KN is a chord, and KN is not a diameter. So I'm going to adjust our definition here and say that the line does not have to pass through the center. Because it can, but it doesn't have to. So the way I wrote it, it makes it sound like the diameter would never be a chord, but that's not true. So just adjusting that definition to make it clearer so that it has endpoints on the circle, does not have to pass through the center, whereas a diameter does. Okay, so let's look at another one, looking at the example on top of 333. So it says to use the circle. This is circle V. So the first question was to name the circle and its center. So it's circle V and the center is point V. How many diameters are shown? So we need lines going through the center. So TW is a diameter. Sorry, shaking a little bit. RS is a diameter, and QP is a diameter. And it doesn't matter which order you write the letters in. Okay. The next question says, is TR a radius? So here is T and here is R. Is this a radius? No, it is not, because it does not touch the center point. This is just a chord. Okay. Number 7, is VX a radius? VX. So, in my book, I don't know what your book looks like. In my book, it would be a no, because the end point is beyond the circle. But I'm hoping in your book the end point is touching the circle, because that's really what they wanted it to be doing. They wanted the end point to actually be on the circle, so that the answer to this would be yes. And it is a radius because it has an end point on the circle and an end point touching the center. Okay, on the next part here, we learn a little bit about some simple closed curves. It's just a path that begins and ends at the same point and does not cross itself. So these would not be simple closed curves, because this one's not closed and this one is kind of crazy. Okay, simple closed curves look like this: a basic circle, an oval, a crazy shape with all rounded edges as long as it doesn't touch itself or go over itself. Okay, so if we look at the figures in this box, some of the simple closed curves are green. So here's a green one, here's a green one, and here's a green one. Those are all simple closed curves, so that is true. Then it says none of the simple closed curves are blue. That is also true, because these cross themselves and these are not closed. All circles are simple curves, simple closed curves. Yes, they all are. And then it says none of the simple closed curves are red. Well, that is false, because we just looked at 4 circles and we just said that all circles are simple closed curves. So if that's the case, then that last one is false, because all these red figures are closed curves. All right, I hope I didn't go too fast. Feel free to watch the video more than once if you need to. Reach out if you have any questions, and have fun. Circles are a lot of fun. Have a great day.